Let us now apply the rational root theorem in finding the roots and factors of a polynomial. Now, to use this method, we will determine first the roots using synthetic division. Now, if the remainder is 0, then P over Q is a root of the polynomial equation. Now, let us start with example number 1. So, we have x cubed plus 3x squared minus 4. Now, we need to identify first the list of the possible rational roots. So we have here P over Q. The list of possible rational roots, or the possible rational roots are, we have positive negative 1, positive negative 2, and positive negative 4. Now we are going to try each possible rational root using synthetic division. So again, in using synthetic division, arrange the terms in descending order, and if there is a missing term, we are going to write 0. So we have here 1, 3, 0, 4x. Since we don't have a term having x as a literal coefficient or variable, then we have the constant negative 4. Now let us start with negative 1. So bring down the first number. We have 1. 1 times negative 1 is negative 1. 3 plus negative 1 is 2. 2 times negative 1 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 1 is positive 2. So the remainder here is negative 2. That means negative 1 is not a root of this polynomial equation. So when we say polynomial equation, by the way, this is equal to 0. So let us try another number. Let us try positive 1. Now this is a trial and error method. Now there is another method, and that is factoring by grouping, but we will focus only in using synthetic division. So let us try now 1. So bring down 1. 1 times 1 is 1. 3 plus 1, 4. 4 times 1 is 4. 0 plus 4 is 4. 4 times 1 is 4. Okay, so we have here now a root. Our first root is 1. Now, since 1 gave us a remainder of 0, we will try again 1 using the coefficients of the quotient. So we have 1, 4, 4. We are going to try again because of multiplicity. We are going to check if 1 has a multiplicity. Rather. So 1. So bring down 1. 1 times 1, 1. 4 plus 1, 5. So 5 times 1 is 5. 4 plus 5 is 9. So in our second try, we didn't get a remainder of 0. So that means 1 has only a multiplicity of 1. When we say multiplicity, that is how many times the root or the number appears as a root of the polynomial equation. So we are going to try another number using the numerical coefficients of our quotient. So we have 1, 4, 4. Okay, let us try 2. So bring down 1. So 1 times 2 is 2. 4 plus 2 is 6. 6 times 2 is 12. So our remainder is 16. That means 2 is not a root of our polynomial equation. Now let us try negative 2. Bring down 1. 1 times negative 2 is negative 2. 4 plus negative 2 is 2. 2 times negative 2 is negative 4. So 4 plus negative 4 is 0. Okay, so we have another root. So we have here negative 2. Now, the numerical coefficients of the quotient is 1 indicates that the quotient is a binomial in linear form or on the first degree. So we can write 1 and 2 as 1x plus 2 or x plus 2. Now we can solve the last root using this binomial. So we have x plus 2 is equal to 0. So x is equal to transpose 2 to the other side. We have negative 2. So we have another negative 2. Now we have here already the roots 1, negative 2, and negative 2. By the way, the degree of the polynomial indicates the number of roots. So since the degree of this polynomial is 3, that means the roots, or we have 3 roots. Now these are our roots. We have one, negative 2 of multiplicity of 2. Why multiplicity of 2? Because negative 2 appears twice as a root of our polynomial equation. Now let us identify the factors of our polynomial equation. So since one of the roots is 1, so we can write this as x equals 1. Then we have x equals negative 2. So transpose 1 to the left side. So we have x minus 1 equals 0. And then x plus 2 equals 0. So the factors of our polynomial equation are x minus 1 and x plus 2 raised to 2. Why raised to 2? Because the root negative 2 is of multiplicity of 2. Now, the shortcut on how to determine the factors using the roots is to change the sign, and then you have to put x as the leading term. So we have here positive 1. So change the sign, it will become negative 1, and then you have to write x as the leading term. Okay, let us proceed to the next example. So we have x raised to 4 minus 4x cubed minus 7x squared plus 22x plus 24. So let us identify the possible rational roots. So p over q is equal to positive negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, positive negative 8, positive negative 12, and positive negative 24. So, wow, we have 1, 2, 3, 4, 5, 6, 7, 8, 16 possible rational roots. So, let us start with negative 1. So, let us write down first the numerical coefficients of our of our polynomial equation. So we have 1, negative 4, negative 7, 22, and 24. Let us start with negative 1. Okay, why did I write this? Very big. Okay, negative 1. So bring down 1. 1 times negative 1 is negative 1. Negative 4 plus negative 1 is negative 5. Negative 5 times negative 1 is positive 5. Negative 7 plus 5 is negative 2. Negative 2 times negative 1 is positive 2. 22 plus 2 is 24. 24 times negative 1 is negative 24. So 24 plus negative 24 is 0. Okay, so we have now the first root, that is negative 1. Now let us try again. Negative 1 for multiplicity. So we have here negative 1. So bring down 1. 1 times negative 1 is negative 1. Negative 5 plus negative 1 is negative 6. Negative 6 times negative 1 is 6. Negative 2 plus 6 is 4. 4 times negative 1 is negative 4. So 24 plus negative 4 is 20. Okay, so we didn't get a 0 remainder on our second try. That means 1 has only a multiplicity of 1. Now let us try another number. Okay, let us try negative 2. So again, this is trial and error. So bring down 1. 1 times negative 2 is negative 2. Negative 5 plus negative 2 is negative 7. Then negative 7 times negative 2 is 14. Negative 2 plus 14 is 12. 12 plus negative 2 is negative 24. So we have here 0. Okay, now we have the second root, and that is negative 2. Now, you have noticed that aside from the last term, which is, or the last number, which is the remainder, we have 3 numbers left. So these are the numerical coefficients of the quotient, which is quadratic. Our quotient here is already quadratic. Now, if you can master how to factor a quadratic equation, you can use that aside from using synthetic division. But if you cannot master factoring quadratic equation, so you have to proceed in finding the roots using synthetic division. Now let us try again negative 2 to check for multiplicity. Okay, we have here 1, negative 7, and 12. So bring down 1. 1 times negative 2 is negative 2. Negative 7 plus negative 2 is negative 9. Negative 9 times negative 2 is 18. So our remainder here is 30. So that means negative 2 has only a multiplicity of 1. Now we are going to try another number. Let us copy first the numerical coefficients of the quotient. So let us try 3. I will not try 8 and 24 because they are not factors of 12. So I am going to cancel these two. I will try 3. It's better to start with smaller numbers. So bring down 1. 1 times 3 is 3. Then negative 7 plus 3 is negative 4. Negative 4 times 3 is negative 12. 12 plus negative 12 is 0. So we have here the third root, which is 3. By the way, how many roots does this polynomial equation have? Okay, very good. It has 4 roots because the degree is 4. Now let us go to the last root, and since we only have 2 numbers left, that is, if you are not going to count the remainder, so we have now 1 and negative 4, we can write this as x minus 4, or 1x minus 4 equals 0. So transpose negative 4 to the other side, so we have 4. Okay, so the last root for this polynomial equation is 4. Now let us list down the roots and the factors. It's raining very hard. The roots are, we have negative 2, negative 1, 3, and 4. And the factors are, the shortcut here again is to change the sign of the root and then write x as your leading term. So we are going to start with negative 2, so it will become positive 2. So one of the factors of this polynomial equation is x plus 2, and then the second one is negative 1. So we have x plus 1, and then 3, so x minus 3, and then the last one is 4, so we have x minus 4. So again, these are the roots and these are the factors. Now let us proceed to the last example. We have 2x cubed plus 11x squared plus 10x minus 8. So let us identify first the list of the possible rational roots of this polynomial equation. When we say root, by the way, that is the number that satisfies the polynomial, or that is the number that will make your polynomial equal to 0. So we have again positive negative 1/2, positive negative 1, positive negative 2, positive negative 4, and positive negative 8. Okay, so let us start now with 1/2. So we have 2, 11, 10, negative 8. So let us start with 1/2. Bring down 2. 2 times 1/2 is 1. 11 plus 1 is 12. 12 times 1/2 is 6. 10 plus 6 is 16. 16 times 1/2 is 8. So negative 8 plus 8 is 0. Okay, so we have now the first root, which is 1/2. Now let us try 1/2 again using the numerical coefficients of our quotient. So we have 2, 12, 16. So okay, no need to divide by the denominator since we are looking only for the roots. Okay, bring down 2. 2 times 1/2 is 1. 12 plus 1 is 13. 13 times 1/2 is 13 over 2, or 6.5. Okay, so 1/2 has only a multiplicity of 1. So let us try another number. Okay, let us try negative 2. So bring down 2. 2 times negative 2 is negative 4, plus 12, that is 8. 8 times negative 2 is negative 16. Okay, yay! We have the second root. Okay, our second root is negative 2. So again, this polynomial equation has 3 roots because the degree is 3. Now, we only have 2 numbers left. That means we can write this as a binomial in the first degree. So we have 2x plus 8 equals 0. So 2x plus 8 equals 0. We are going to transpose 8 to the other side. So 2x equals negative 8. Then divide both sides by 2. So x now is equal to negative 4. And this is the last root. We have negative 4. So the roots of this polynomial equation are 1/2, negative 2, and negative 4. The factors are, again, change the sign of the roots. So we have x minus 1/2, and then x plus 2. Sorry, since negative 4. And the last one is x plus 4. Now, x minus 1/2 can be written as 2x minus 1. Just make the denominator of your quotient as the leading coefficient. And then we have x plus 2 and x plus 4. So these are the roots of the polynomial equation, and these are the factors.